You're surrounded by stars. Hundreds of billions of them, in every direction, as far as telescopes can see. And you're completely alone. The nearest star, after the Sun, is Proxima Centauri. You can see it through a telescope. You can measure it. You can calculate its distance, its mass, its temperature. But you can't reach it. You can't reach any of them. There's something between you and the stars. Not empty space. Something else. A barrier built into the structure of the universe itself. Tonight, we're exploring that barrier. A barrier made of time itself. And it's a barrier we will never cross. Let's begin. The barrier starts close. The Sun is 150 million kilometers from Earth. In light travel time, 8 minutes. The sunlight you see right now left the Sun 8 minutes ago. It crossed 150 million kilometers of space at 300,000 kilometers per second and reached your eyes. The Sun you see isn't the Sun as it is. It's the Sun as it was. If the Sun vanished right now, just disappeared, you wouldn't know for 8 minutes. The light would keep coming. The sky would stay bright. You'd be living in a universe that no longer existed. And you couldn't know. For 8 minutes, you'd be trapped in the past. That's the nearest star, and we can't even see it as it is now. Voyager 1, launched in 1977, now at the edge of the solar system, is almost a day away in light travel time. When we receive a signal from Voyager, it's almost a day old. We're communicating with the past. Even here, in our own solar system, we're separated by time. And beyond Voyager, the separation grows. The Oort Cloud, the true edge of the Sun's gravitational influence, may extend out to a light year or more. A full year or more for light to cross. But beyond that edge, distance changes. It's no longer measured in kilometers, but in lifetimes. And if you think reaching the nearest star is just a matter of speed, well, you're about to see why you're wrong. Proxima Centauri is the nearest star to Earth after the Sun. 4.2 light years away. Let's make that distance real. In kilometers, 4.2 light years is about 40 trillion kilometers. If you could somehow drive there at highway speed, 100 kilometers per hour, it would take 45 million years. The entire span of primate evolution. The fastest spacecraft ever built, NASA's Parker Solar Probe, reaches speeds of about 190 kilometers per second. At that speed, it would take 7,000 years to reach Proxima Centauri. 70 centuries. The entire span of recorded human history. Voyager 1 travels at 17 kilometers per second. At that speed, 73,000 years. longer than modern humans have existed. And if you could travel at the speed of light, which you can't because physics won't allow it, it would still take 4.2 years. 4.2 years of travel at the fastest speed possible in this universe, just to reach the nearest star. And when you arrived, everyone you left behind would be 4.2 years older. The Earth you departed from would be in the past. You couldn't return to the world you left. That world would be gone, changed, aged, moved on. Because traveling through space means traveling through time. And time only moves forward. You'd arrive at Proxima Centauri alone. Not just physically alone, temporally alone. Separated from everyone you knew by years you can never recover. And the space between? Empty. No planets, no asteroids, no dust clouds thick enough to see. Just void. Around 1/10 of an atom per cubic centimeter. Still emptier than any vacuum we can build on Earth. Darkness so complete that if you were halfway between the Sun and Proxima Centauri, both stars would look like distant points of light. Faint, cold, unreachable. You'd be alone in a darkness that has no reference in human experience. Millions of kilometers from anything solid. Years of travel in any direction before you'd reach a star. This is interstellar space. This is isolation. And this is the closest star. The stars you see at night, the ones scattered across the sky, are dozens to hundreds of light years away. When you look at the Big Dipper, you're seeing light that left those stars decades to centuries ago. Some of those stars might already be dead. Their light is still traveling toward us. Ghosts in the night sky. The Milky Way is 100,000 light years across. 100,000 years for light to travel from one edge of the galaxy to the other. Let's try to understand that. Light, traveling at 300,000 kilometers per second, crossing the distance from Earth to the Moon in 1.3 seconds, would take 100,000 years to cross the Milky Way. It would have started when early humans were in Africa, before language, before art, before we left the continent. And it still wouldn't have reached the other side. 100,000 years is roughly 1,250 human lifetimes. If you lined up every generation, parent to child to grandchild, from the beginning of that journey to now, you'd have 4,000 generations. 4,000 generations of humans, each one living and dying, while that single photon crossed the galaxy. At Voyager 1's speed, it would take 1.7 billion years to cross the Milky Way. 1.7 billion years ago, Earth had only single-celled life. No plants, no animals, no complexity, just bacteria and archaea. Multicellular life wouldn't appear for another billion years. Fish wouldn't exist for 1.2 billion years. Dinosaurs wouldn't walk for 1.5 billion years. And humans wouldn't appear for almost 1.7 billion years. That's how long it would take to cross one galaxy. We're about 26,000 light years from the galactic center, from Sagittarius A star. The light we see from the center of our own galaxy left 26,000 years ago. Humans were living through the last ice age. No cities, no agriculture, no writing, stone tools and firelight, and small bands huddled against the cold. That light has been traveling ever since, across 26,000 light years of space, while human civilization rose and fell, and rose again, while empires were built and destroyed, while languages were born and died. That light is older than recorded history, and it's still considered close. The Milky Way contains 200 to 400 billion stars, each one separated from its neighbors by light years. Hundreds of billions of stars, each one isolated by years of light travel. We're bound to our corner of the galaxy, not just by distance, by time, by the speed limit of light itself. Everything we've seen so far, the billions of years, the thousands of generations, has all been contained within this one island. But if you think the space between stars was the barrier, well, you're about to see just how lonely the universe can get. Let's leave home. Andromeda is 2.5 million light years away. 2.5 million years for light to cross the space between galaxies. The light we see from Andromeda left when the first humans in our genus were just beginning to appear on Earth, long before Homo sapiens, before stone tools were refined, before fire was controlled, before language existed. That light has been traveling for 2.5 million years, across a void so vast it makes interstellar space look crowded. At Voyager speed, it would take 43 billion years, 3 times longer than the universe has existed. And the space between the Milky Way and Andromeda? Emptier than anything you can imagine. If you could somehow be suspended halfway between the two galaxies, 1.25 million light years from either one, you'd be surrounded by a darkness so absolute it defies description. Both galaxies would be faint smudges of light, barely visible. You could hold up your hand and each galaxy would fit behind your thumbnail. No stars nearby, no planets, no structure. About 1 atom per cubic meter. Intergalactic space. You'd be 1 million light years from the nearest star. 1 million years of light travel in any direction before you'd reach anything solid. No one within 1 million light years to hear you. You'd be more alone than any human has ever been. More alone than it's possible to be on Earth. Alone in a way that has no comparison in human experience. This is intergalactic space, the deepest isolation in the universe. And Andromeda is our nearest large neighbor. Beyond the local group, the small collection of galaxies that includes the Milky Way and Andromeda, the distances grow even larger. Each one separated by voids we can measure, but never cross. The universe is full of places we can see but never reach. But as we push further out, toward the very edge of the light we can detect, we find the final version of the barrier. It isn't just that the stars are far away. It's that the ground beneath them is moving. Let's look at the horizon and what lies beyond it. The observable universe is about 93 billion light-years across. The universe itself is 13.8 billion years old. But space has been expanding since the Big Bang, stretching the fabric of the universe itself. So the observable universe, the part we can see, is much larger than 13.8 billion light-years. TON 618, one of the most massive black holes ever discovered, is about 18.2 billion light-years away in today's expanding universe terms. But its light has been traveling for about 10.8 billion years. That light started its journey when the universe was young, when the first galaxies were still forming, when stars were igniting for the first time across the cosmos. It traveled for 10.8 billion years, across expanding space, through the void between galaxy clusters, past billions of galaxies, until it reached a telescope on Earth. What is TON 618 doing right now, in this present moment? We have no way of knowing. Light from TON 618's present day won't reach us for another 10.8 billion years. By then, the sun will have died. It will have swelled into a red giant, consumed the inner planets, shed its outer layers, and collapsed into a white dwarf. Billions of years will have passed. Earth, if any trace of it remains, will be a cold, dead cinder orbiting a dying star. Humanity will be gone, either extinct or evolved into something so different we wouldn't recognize it as human. What separates us from TON 618 is 10.8 billion years of unreachable present. And TON 618 isn't even close to the edge. The farthest light we can see, the cosmic microwave background, is 13.8 billion years old. The afterglow of the Big Bang itself. The very first light that could travel freely through the universe. That light has been traveling since the beginning, across the entire history of the universe. From a time when there were no stars, no galaxies, no planets, just hot, dense plasma, cooling and expanding. That light left when the universe was 380,000 years old. And that marks the edge of the observable universe. Not because the universe ends there, but because that's as far as light has had time to travel. Beyond that, the universe before light could travel? Unknowable. Unreachable. And here's the devastating part. There are galaxies out there, right now, whose light will never reach Earth. Because space itself is expanding faster than their light can cross it. Those galaxies exist, stars forming, planets orbiting, maybe life. But we will never see them. Never. Because their light will never reach us. We're isolated by the structure of space-time itself. A light year is a unit of distance, 9.46 trillion kilometers, the distance light travels in 1 year. But it's also a unit of time, a unit of separation, a measure of how trapped we are. When you look at something 10 light years away, you're experiencing two things at once. It's 94.6 trillion kilometers from you, and the light reaching your eyes left that object 10 years ago. Distance and time collapse into each other. They're inseparable. Humans evolved to understand distances we can walk. 100 meters, a kilometer, 10 kilometers. These distances make sense to us. But a light year? If you tried to walk 1 light year at a normal pace, 5 kilometers per hour, it would take 214 million years, longer than dinosaurs have been extinct. If you drove at highway speed, 100 kilometers per hour, it would take 10.8 million years, longer than the entire genus Homo has existed. If you flew on the fastest spacecraft ever built, Parker Solar Probe, at 190 kilometers per second, it would take 1,576 years. 1 light year, and the nearest star is 4.2 of them away. People sometimes try to make cosmic distances comprehensible by scaling them down. If the sun were the size of a grain of sand, Proxima Centauri would be another grain, hundreds of kilometers away. The Milky Way would stretch millions of kilometers. But even scaled down, the numbers are incomprehensible. There's no metaphor that makes a light year feel real, no comparison that makes it graspable. The human brain isn't built for it. And that's the point. The universe operates on scales we're not equipped to understand. Distances measured in years of light travel, voids so vast that even traveling at the cosmic speed limit, you'd spend lifetimes in darkness. Barriers of time we can never cross. We're small. The universe is vast. If you could somehow travel to another galaxy, you would arrive alone. Everyone you knew would be millions of years dead. The civilization you left would be ancient history, or forgotten entirely. The Earth you departed from would be unrecognizable. You could never go home. Not to the place you left. That place would be gone, erased by time. And this isn't science fiction. This is physics. Distance in space means separation in time. And time only moves forward. Every light year is a year you can never recover. Every journey is one way. The moment you depart, the place you left begins aging into something else. By the time you return, it's gone. This is why the stars are unreachable. Distance doesn't just measure space. It measures what you lose by crossing it. That's what a light year means. Separation you can never undo. Time you can never get back. Moments you can never return to. And every photon that reaches your eye tonight has traveled across space and time to show you a universe that is already gone.